Hello everyone. In this video I'm going to be talking about integration. So indefinite integration to be more specific. So there were a few problems that were asked, one, two, three, and I think total of four questions were asked on indefinite integration. So let us just look at these problems one by one. So first problem is integral of tangent inverse of x divided by x cube. Now, in this problem, the first method that I would say everybody chooses is by parts, and by parts is what we are also going to do. But whenever you do by parts integral, you have to make sure that you choose the correct functions. Which one has to be differentiated, which one has to be integrated. As we all know, integral of uv is equals to u into integral of v minus integral of differential of integral of v. Now this whole is also integrated. So we want to choose the functions in by parts integration such that the integral of the function is easy, and also the differential is also easy for the one which we want to choose as u. Its differential should be easy, and the function that we want to choose as a v, its integral should be easy. Okay, so when I look at this divided by x cube, so it's x raised to the power minus 3 into tangent inverse of x in simpler terms. So if I integrate x raised to the power minus 3, I will get x raised to the power minus 2. So, or in other terms, I will get x square in the denominator. So dealing with x square in the denominator is much easier than dealing with x cube in the denominator. So I am going to be choosing u as tangent inverse of x and v as 1 by x cube, and then I will apply the by parts integration. So let us look at that. I have done it over here. So integral of uv is equals to u times integral of v minus whole integral of du into integral of v. Okay. So I have chosen u as tangent inverse of x and v is equals to 1 by x cube. So I is equals to u into integral of v. So u stays as it is, which is over here, and integral of x raised to the power minus 3 minus differential of tangent inverse of x into integral of x raised to the power minus 3 dx. Okay. Now we all know what is the differential of tangent inverse of x. It is 1 by 1 plus x square. I have done that over here. And integral of x raised to the power minus 3 is x raised to the power minus 2 divided by minus 2. Since integral of x raised to the power n dx is equals to x raised to the power n plus 1 divided by n plus 1 plus c. Okay, we are not too bothered about c right now. So if n is minus 3, it will become minus 3 plus 1. So x raised to the power minus 2 divided by minus 3 plus 1 is minus 2. So minus 1 by 2 into x raised to the power minus 2. Okay, and tangent inverse stays as tangent inverse. Differential of tangent inverse is 1 by 1 plus x square. Again, integral of x to the power minus 3 is x raised to the power minus 2 by minus 2. So this is done. Okay, we are not bothered about this part now. Now we have to look at this. So minus and minus becomes plus. So 1 by 2 outside, and integral of 1 divided by x square into 1 plus x square. Now I have x square into 1 plus x square in the denominator. This looks like a problem of partial fractions now, because I can easily write 1 by x square into 1 plus x square as 1 by x square minus 1 by 1 plus x square. How? If I have 1 by x square minus 1 by 1 plus x square, if you take the LCM, what you will get? 1 plus x square over here and minus x square over here, and the product of x square into 1 plus x square in the denominator, right? Don't mind my writing, I'm using a mouse. So x square and x square will get cancelled. You will get only 1 in the numerator, which was what was originally given to us. So this whole thing can be written as 1 by x square minus 1 by 1 plus x square. So that is very easily differentiable, okay? But since half is multiplied outside both the terms, So half of 1 by 1 plus x square dx minus half of integral of 1 plus x square dx, 1 by 1 plus x square. We know that this integral will be tangent inverse of x, and this one will be what? Increase the power by 1 divided by the new power. So x raised to the power minus 1 by minus 1 or minus 1 by x, which I have mentioned over here. Okay, so my I is equals to minus half of tangent inverse of x by x square minus 1 by 2x minus 1 by 2 tangent inverse of x plus c. You can simplify and rearrange it as asked in the problem, and as you can see, option C is the correct one, right? Yeah. Now let us look at question 2. So this one I think is a bit trickier compared to problem 1. I mean, problem 1 is very fairly straightforward. Just do the by parts and do the partial fraction. In this problem, you don't really know if you can do partial fraction or you can do by parts. But in my experience, whenever I have seen such problems, when I convert them to sine and cos, the problem is always much easier to solve. So I will do that over here as well. I will convert all of this expression into sine and cos, because first, the differential of sine and cos is easier to obtain compared to tan and cotangent. It always I used to end up make mistakes in this. So in my JEE exam as well, during the preparation, I would convert tangent and cos into sine, tangent and cotangent into sine and cos. So I've done that over here as well. So the given expression is 1 minus cot raised to the power 2019x divided by tan x plus cot 2 raised to the cot raised to the power 2020x. Okay. So cot is what? Cos by sine, and tan is what? Sine by cos. Again, cot is cos by sine. So I have 1 minus cos raised to the power 2019x divided by sine raised to the power 2019x whole divided by sin x by cos x plus cos raised to the power 2020x divided by 2 sin raised to the power 2020x. Okay. Now when you add sin x by cos x plus cos 2020x by sin 2020x, the LCM will be sin raised to the power 2020x into cos x. Okay. And over here, sin raised to the power 2019x will stay in the denominator. 1 will multiplied by sin 2019 is sin 2019x. So you will get sin raised to the power 2019x minus cos raised to the power 2019x divided by sin raised to the power 2019x. Okay, and over here you will get sin raised to the power 2020x and cos x. This whole will go into the numerator because this expression is in the denominator. So sin 2020 will go into the numerator. It will get divided by sin 2019. So only sin x will remain and cos x will also be there. So this is the expression after converting this whole thing into sin and cos, which is sin raised to the power 2019x minus cos 2019x into sin x cos x divided by sin 2021 plus cos 2021x. So this is very simple arithmetic, just plus minus multiply divide LCM etc etc. Everybody of class 11th or 12th student can do that. Now comes the real problem. How do I proceed forward from this? If I just assume sine raised to the power 2021x plus cos raised to the power 2021x equals to t, what will be dt? Or if I take the differential with respect to x on both sides, what will I get? Bring the power down, so 2021 here, decrease the power by 1, so this becomes sine 2020, and differential of sine, we know the differential of sine is what? Cos x. Now bring the power down, 2021 here, decrease the power by 1, 2021 becomes 2020 cos x, and differential of cos x. What is differential of cos x? We know that it's minus sin x, so minus sign comes over here. This is equals to dt by dx. Okay, so what will be sine 2019x minus cos 2019x into sin x into cos x into dx? This will be equal to 1 by 2019 dt. Why have I done this? Because this is in the numerator of this expression. right? Since dx is also there. So this whole thing in the numerator will become 1 by 2019 dt, and the denominator will be t, right? So 1 by 2021 into integral of dt by t. Now we know that integral of dx by x is log of x. So integral of dt by t is log t. When the base is e, you can write log as ln. And we use mod because logarithms of only positive numbers is defined. Otherwise, this becomes undefined or complex number. So 1 by 2021 ln mod of t. Now what was t? Sine raised to the power 2021x plus cos raised to the power 2021x. So I have mentioned that over here. Now let us compare this to what we were given in the problem. The whole integral is given to be equal to 1 by n into ln of mod of fx raised to the power n plus gx raised to the power n. As we compare this to this, we can see that n equals to 2021 and fx is equals to sin x and gx is equals to cos x. Okay, so now we have almost solved the problem. What has the guy asked us to do next? Find out the value of n into fx raised to the power 4 plus gx raised to the power 4 when x equals to pi by 3. So I know fx, I know gx, I know n, so I can easily do it now. So this will be what? 2021 times fx raised to the power 4 at x equals to pi by 3. Sine pi by 3 is equals to root 3 by 2. Root 3 by 2 raised to the power 4 is what? Root 3 into root 3 into root 3 into root 3 is, so that's equal to 3 times 3, which is 9, and 2 raised to the power 4 is what? 16. Cos x at x equals to pi by 3 is cos 60 is half, and 1 by 2 raised to the power 4 is 1 by 16. So this 9 by 16 plus 1 by 16 is 10 by 16. 2021 into 10 by 16, you can do this, 5, 8. So 2021 times 5 is 10105 divided by 8. So option D is correct. So this wasn't really a tough question if you knew how to attempt it. I mean, if you start doing by parts or partial fraction or this or that or blah blah blah, you will not be able to solve the problem in given time. You will take 10 to 15 minutes, and that is very bad in an exam like this one, in which you have to solve 80 questions of maths and 80 of physics and chemistry in a given time period. So that's very tough unless you take the correct approach. Now let's look at problem number 3. Again, this looks like a very tough problem on the face. The face is very bad. It's a very ugly looking question. The integral is x cube plus x square minus x minus 1 whole in the numerator divided by, because there is a x raised to the power 5. Whenever there is this many big powers of x or y in the integrals, you can just assume that this is going to be a headache to solve. X raised to the power 5, x raised to the power 4, x cube, x square, x1, and on top of that this guy has put tangent inverse of x square plus 1 by x as well in the denominator, not even numerator, in the denominator. So this is going to be a huge headache for anyone who tries to just dive right in without thinking how to solve this problem. Okay, one thing that I can see that may be of help to us is, I think I can factorize this, right? You take x square common, you will be left with x plus 1. You take minus 1 common, you will be left with x plus 1. Similarly, this is also very easily looking fraction expression, and you can easily factorize. Take x raised to the power 4 common, you will be left with x plus 1. 3x square common, x plus 1. 1 common, x plus 1. So x plus 1 is common in numerator and in the denominator, so I can just cancel x plus 1 out. And how can I do that? Because x is not equal to minus 1. Okay, it's given to us. X is not equal to 1. It should have been x is not equal to minus 1. So whatever. Let's just try and solve this. Numerator can be factorized. X square into x plus 1 minus 1 into x plus 1. So x square minus 1 into x plus 1. And x raised to power 5, 4, 3, 2, 1. I just told you how to factorize this. If you take x plus 1 common, you will be left with x raised to power 4 plus 3x square plus 1. So this whole expression can be mentioned as this, right? Now I don't know what to do with this, so I just assumed it as t. Tangent inverse of x square plus 1 by x equals to t. Okay, let's just pray to God and start solving from here. Maybe everything will work out. So when I differentiate this thing with respect to x, what will happen? Differential of tangent inverse of x, we know that 1 by 1 plus x square. So 1 divided by x square plus 1 whole square divided by x square. And the differential of this whole thing, x square plus 1 by x, which is equal to dt by dx. When I solve this, what will I get? X square divided by x4 plus 3x square plus 1. How? Because the x square is in denominator and this whole thing is divided by 1, so x square will go into the numerator and you will be left with x square in denominator plus x square plus 1 whole square. Now a plus b whole square is a square plus b square plus 2ab. So x square will be x raised to the power 4 plus 1 plus 2x square. So 2x square plus x square will become 3x square, which is I have written over here. Differential of x square plus 1 by x, you can write it as x square by x plus 1 by x, right? So this will get cancelled. You will be left with x plus 1 by x. Differential of x is 1. Differential of 1 by x is minus 1 by x square. So this whole into dx equal to dt. Now when I solve this, x square minus 1 and x square in the denominator, x square and x square will get cancelled. So I will be left with x square minus 1 divided by x raised to the power 4 plus 3x square plus 1 into dx is equal to dt. What was our given expression? X square minus 1 by x4 plus 3x square plus 1, right? So I have gotten rid of this whole thing. This whole thing is just absolutely simply vanished. This thing has vanished. What will my integral reduce to? Dt by t. That's it. T, because tangent inverse of x square plus 1 by x square was t. The rest of the thing becomes dt. So integral of dt by t, again ln mod t plus c. What is t? Tangent inverse of x square plus 1 by x. Now let us compare that to what was given to us. He says this is equal to a times log of fx. So what is a? It's 1 here, right? I can just say this is 1 multiplied with this. 1 into anything is anything. So a is equals to 1 and log of fx. This is log of this. So fx is what? Fx equals to tangent inverse of x square plus 1 by x. Easy. Now what is being asked to us? A minus tangent of f of 2. A minus tangent of f of 2 is 1 minus tangent of tangent inverse. They will get cancelled. So x square plus 1 by x. X is mentioned as 2. So 2 square plus 1 by 2. 2 square is 4. 4 plus 1 by 2. 5 by 2. 1 minus 5 by 2 is minus 3 by 2. Minus 3 by 2. Option A is correct. So this was a kind of a lucky break. I just assumed tangent inverse of this whole thing as t and everything just worked out. I had to take a fraction of this and fraction of I had to factorize this and factorize this. X plus 1 was cancelled. We got lucky and the problem is solved. Let us look at problem number 4. If I subscript n is equals to integral of x raised to the power n sin x dx, and this whole thing is given blah blah blah, then what is f1 plus g1? So to get to f1 plus g1, I need to know what is fx plus gx. To know fx plus gx, I need to find out i6 and i2. Then I need to subtract them. Then I will have to compute this whole thing. Then I will have to compare what is multiplied with fx, what is multiplied with gx. Then I will be guessing like, oh, so this is fx and this is gx. Then I will put value of 1 in there, and then I will be able to find f1 plus g1. It's a whole lot of work in this problem, but the good thing about this question is it's a very standard problem. Everybody knows integral of x raised to the power n sin x or x raised to the power n cos x, one and the same thing. So let us just consider this. In equals to integral x and sin x. What do? I don't have anything other than by parts, so I'll just go by parts. u will be x raised to the power n, obviously, because integral of sine is very easy, cos x. If I take x raised to the power n as v, this will get integrated to x raised to the power n plus 1. So I will be making my problem much worse. I need to reduce this power in order to be able to solve it. Okay, so I am doing by parts. U is x raised to the power n and v is equals to sine x. So in will be what? X raised to the power n integral of sine x minus differential of x raised to the power n. What? That will be what? Bring the power down, decrease the power by 1. So n into x raised to the power n minus 1 and integral of sine x dx and the whole integral. Okay, integral of sine is minus cos, we know that. N is constant, I am taking it out. So I am left with x raised to the power n minus 1 cos x. Integral of sine is minus cos. So this minus and this minus will become plus. Okay, so I am now left with this x raised to the power n cos x. I will apply by parts again. I have gotten rid of n. Now I am left with n minus 1. Now I want to further reduce this power to n minus 2. So I am going to do by parts again. So n is a constant which is outside, so over here u will be what? X raised to the power n minus 1 and v will be what? Cos x. So x raised to the power n into integral of cos x minus differential of x raised to the power n minus 1, which will be n minus 1 into x raised to the power n minus 2 and integral of cos x. Integral of cos x is plus sin x, so this minus will stay here, so sin x. Okay, x raised to the power n minus 2, n minus 1 is constant, it will go outside. Integral of cos is sine. Okay, so in is what? Minus x raised to the power n cos x plus n x raised to the power n minus 1 sin x minus n into this, so n into n minus 1 into integral of x raised to the power n minus 2 sin x dx. Now if in was x raised to the power n sin x dx, so in minus 2 will be x raised to the power n minus 2 sin x dx. So that I have put over here. So in is reduced to in minus 2 with this whole thing attached to it. Okay. So what will be I6? Just put n equals to 6 in this expression, which will be n is replaced by 6. So minus x raised to the power 6 cos x plus 6 into n minus 1 is 5, 6x5 sin x, 6 into 6 minus 1, 6 times 5 is 30, minus 30 I4. In the problem I am given I6 and I2, not I4, so I will have to get rid of I4. How will I get rid of I4? I will put n equals to 4 in this one. Okay, so I4 will be what? Minus x raised to the power 4 cos x plus 4x cube minus 4 into 4 minus 1, 4 into 3 is 4 into 3 is 12. Why have I written I don't know. So this is 12, not 6. Apologies. 4 times 3 is 12. So minus 12 I2. Okay. Now minus 12 here again. 12 times 3 is 360. Okay. So I6 is equals to minus x6 cos x plus 6x5 sin x minus 30 into minus x raised to the power 4 cos x plus 4x cube sin x minus 12 by 2. This value of I4 that I got from here I will put in this equation and I will get this. So when I simplify this expression, I will get I6 minus 360 I2 is equal to minus x raised to the power 6 plus 30 x4 into cos x plus 6x5 minus 120 x cube sin x. This was given equal to, in the problem, I6 minus 360 I2 was given equal as fx into cos x plus gx into sin x. So when I compare, I will get fx equals to minus x raised to the power 6 plus 30 x4 and gx I will get equal to 6x5 minus 120 x cube. So f1 plus g1 will be what? Minus 1 plus 30 plus 6 minus 120, which is equal to minus 85. Minus 85, the correct option is A. Okay, so we have done indefinite integrals, 4 problems in this video. Next I will continue with definite integrals. Thank you everyone.